So this one is our last article, surface and volume of revolution about an x-axis. The article is from integral calculus. Remember, uh, this article is in IMU syllabus from last 7-8 years, but not a single question is coming on this article in final exam. Okay, it's not so important article, but it is a part of our syllabus. So just quickly, we are going to finish it today only. So come to the topic, surface and volume of revolution about an x-axis. That is a topic that we have in our syllabus. So for this topic, yes, you should know the rectification first. What is a rectification? The rectification is a process. This rectification is a process of obtaining the length of the curve. Okay, length of the curve. So finding the length of the curve from the small length, that process is known as a rectification. We are rectifying the small length to the entire length of the curve. So how it is obtained, let me see it here. So let me assume that we have to find the length of this curve from x equal to a to x equal to b. So x equal to a and x equal to b, these are the points in which we have to find out the length of the curve. Suppose the entire length of the curve is s. So for that, a very small length ds is taken. So this ds is a very small length. You will observe here. This when ds is a very small, this ds is acting like a straight line. And if you observe this horizontal distance, if you take it as a small dx and vertical distance as small dy, okay, so we get a relation between dx, dy and ds. Yes, anyone? What is that relation? What should be the relation between ds, dx and dy, provided ds tends to a 0?
ds is equals to dy by dx.
dy by dx.
No. It is a relation that we get. It as a ds square is equal to dx square plus dy square. It's by Pythagoras theorem. Okay. So, provided ds tends to a 0, this is the relation we get, and indirectly we get a value of a ds as square root of, if we take dx square as a common, 1 plus dy by dx bracket square into dx. And this ds is known as a very small length d, that is a very small length of the arc length s there. And if you want the entire arc length s, it is obtained by integration from x equal to a to x equal to b of that small ds. And if we replace the value of this small ds and we integrate it from a to b, we get the entire length of the curve. This process is known as a rectification. Okay, so what is the important thing that you have to remember? You have to remember only this important formula of a ds only. This ds is a very important formula that we require in surface and volume of revolution. So let I show you the formulas of a ds for Cartesian, parametric and the polar curves. So here are the formulas that you have to remember. The first one, for y equal to fx, the small arc length ds is given by this formula, which is square root of 1 plus dy by dx bracket square into dx. If the curve is in a parametric form, say x and y available in terms of a parameter t, then ds is given as a root of dx by dt square plus dy by dt square into dt. So this is another formula. And the third formula, r equal to f theta. In such a case, ds is given by square root of r square plus dr by d theta bracket square d theta. So that about the three formulas without a derivation. The derivation will not come in the exam. So the formula of a ds is mainly the important. So that about the step number 1 for surface and volume of revolution. Now we'll come to our main article, main topic. So main topic is a surface area and volume of revolution.
Excuse me, sir.
Yes.
So is there PDF of this topic now?
Yes, PDF.
Yes, will you share a PDF?
Yes. I will share, definitely. I will share this PPT with you. Okay. Whatever the PPT I'm showing right now, this PPT I will share after the session. Okay, just after the session. Okay. So surface area and volume of revolution. Now, what is this thing? So see here, we have some curve, say y equal to fx. This is the curve y equal to fx. This much is the curve only y equal to fx. We are rotating this curve about an x-axis. So whenever we rotate the curve about an x-axis, it generates some solid. Okay, right now the solid is looking like this. You will observe these are the boundaries here. So these are the boundary equation. and the solid is looking like this. So that about the solid. So when we rotate the curve y equal to fx about an x-axis, it generates some solid, and that solid will have a surface area, obviously only curved surface area. We are not considering this area. Okay, remember, these surface areas are excluded, only curved surface area. We are interested in this area, curved surface area. And another thing, volume of such a solid when it rotated. So to get these two things, we have the formulas now. So the formulas are very simple to remember. Let I ask you, suppose we take any point p of xy, we take any point p of xy on that curve. What about this vertical height? What about
Y.
the
Y.
y? Okay. So, and suppose this ds is a very small arc length, ds is a very small arc length. So what is the surface area of the disk? What is the surface area of a disk which we rotate about an x-axis? Only curved surface area I want. What will be the curved surface area of the disk which we are rotated about an x-axis? So this, when you rotate this small ds only, when you rotate this small ds about an x-axis, it gets a disk. Is it clear? It's just like a coin.
Yes, sir.
So
Yes, sir.
what about that
2
surface area?
4 pi s square.
2
2 pi
pi
s.
y
2 pi y
y ds.
2 ds.
Okay. So 2 pi y ds will be the surface area of that small disk, and we are interested to get the entire surface area. So entire surface area is given as x equal to integral from x equal to a to b, and that is a surface area. So this is the formula for surface area that you have to remember. Surface area formula is integration a to b 2 pi y ds. And what is the value of ds? Yes, anyone? How we get a ds?
Root 1 plus dy by
Yes, very good.
dx.
That's correct. Root
What?
of 1 plus dy by dx, bracket square into dx, and that ds is nothing but it is small arc length, and that we seen in the previous, on the previous slide there. So this is the first thing that we require for surface area. Now for a volume, if we come to the volume, it requires a little different thing. We are not considering the curved surface area. Instead, we taken a very small thickness of that disk. The thickness of the disk is a dx. Suppose dx is the thickness of a disk. So what will be the volume of that disk? Volume of a disk with dx as a thickness at a point p of xy.
Pi y square ds.
I y square ds.
Correct. It is a pi y square. Instead of ds, why we are not taking ds? ds is a curved area, while dx is a thickness or a height of that solid. So pi y square dx from a to b again. So this gives us a volume. So that are only the two formulas you should remember. So two most important formulas that you have to remember. Surface area is a 2 pi y ds, while the volume is a pi y square dx. Okay, pi y square dx, that about a formula for volume. Let I show you all these formulas. So these are very important formulas. Everything is tabulated here. So first you should know the ds value. So ds value is written here. Surface area for a Cartesian curve y equal to fx is integral 2 pi y ds from integral a to b, or x1 to x2, whatever the limit of x there. So that about surface area. Volume formula is a pi y square dx. Okay. Now you'll observe the same formula is for parametric also. Parametric is same formula. So what is the difference? The difference is only the value of y we can replace as a yt from here, and the value of a ds we replace from this formula there. Okay. Similarly here y value is replaced from y equal to yt there, and dx is taken as this is the dx into dt there. Okay, so whatever the, suppose x is t square, so dx is a 2t dt, so that you have to replace. So formula remains same, only the corresponding values you have to replace from the given equation. That for a parametric. Polar, you should take a precaution here. Okay, there is a little bit important thing that you should remember. Yes, for surface area there is no change. Same formula we are using, 2 pi y ds, where ds we replace by using this formula, and a value of y. What is the value of y in a polar? Yes, anyone? What is the value of y?
R sin theta.
Yes, correct. R sin theta you have to replace. Y you have to replace by R sin theta, and ds you have to replace by this formula. You will get a
Under
surface
root.
area. Okay, but for volume you have little different formula that you have to remember. We are going without derivation, so I am saying you just remember these formulas, you will get the answers. Okay, so 2 by 3 pi r cube sin theta d theta gives us a volume of a solid which we rotate about an x-axis there. So that about the formulas. Remaining things is just calculation now. Okay,
Sir,
yes, yes.
sir, what about the limit in surface area of revolution in polar form?
Limit of rotation is always in terms of a theta. So here, even though I say x1 to x2, so this you have to convert into theta 1 to theta 2 there. Okay.
Okay, sir.
So all these are because we are rotating some curve between some angles like theta equal to 0 to theta equal to pi by 2. So 0 to pi by 2 curve, that part only we are rotating about an x-axis. Instead of x-axis, here word is used as initial line. Okay, that is only the difference. So in our syllabus, only rotation is about x-axis. Okay, you can go through the syllabus and you will clearly observe it is written only about an x-axis there. So come to the example now. The question number 1. This question we already done. Okay, we already completed this question. We calculated the volume of a sphere of radius a. But here we are going to find the volume by the method of rotation or surface of that we are rotating the curve about an x-axis here. So tell me which curve we should rotate about an x-axis to generate the sphere first. What should be the curve we should rotate? Yes, anyone?
Second.
Circle. Yes, you can rotate a circle or semicircle. Both are correct answer. So here is the first one. We consider, let me assume, a circle which we rotate is x square plus y square is equal to a square. So this circle we are rotating about an x-axis, which generates the sphere. So what is the formula for volume first? Yes,
Pi y square dx.
pi y square dx. Correct. So volume is 2 times integral 0 to a pi y square dx is written. Why 2 times? Because I'm going to rotate
The
the,
symmetric.
yes, I'm only rotating this arc. So if you're not happy to rotate only arc in the first quadrant, you have to give the limit minus a to plus a, is it? So limit of x, either you take minus a to a, so this one v is equal to integration minus a to a pi y square dx. So this is one way, or this is the other way. I hope no one have the problem with this formula. 2 times 0 to a pi y square dx is taken. The limit of x is taken from 0 to a. So you'll observe x varying from x equal to 0 to x equal to a. So this arc is only rotating. So value of y square. So you can see this equation, x square plus y square is a square. So what is y square? Y square is a square minus x square, is it? So value of y square is replaced, and now a very simple thing that left. It is just integration with x and putting upper and lower limit there. What is the integral of a square? It's
Cube
A
by 3.
square x.
a square x,
square
and
x.
this is a x cube by
X
3.
cube by 3.
So that's one. So simple integration, limits 0 to a, put upper limit minus lower limit, and you will observe the required answer should be, yes, the volume of a sphere is
4 by 3 pi cube.
correct, 4 by 3, and that is the end of a question here. So the questions are really a simple. Important thing, you should get a correct formula with the correct limits there. So limit is from 0 to a or minus a to a, but when you take 0 to a, it should be 2 times there. That's one. Any doubt in the question one?
No, sir.
No. Okay. So
No, sir.
come to the next question. There are two new curves are coming here in two of the examples. Let me see one by one that. So here is one new curve for you. First of all, the question is find the volume of a solid which rotated about an x-axis enclosed between the parabola. Y square equal to 4x is not a new curve, but this curve is a new. 27ay square equal to 4 times x minus 2a bracket cube. Okay, so this is the solved example in a textbook. Let I show you this curve. Obviously, this curve x equal to 2a, y is a 0. When x equal to 2a, y is a 0, So this curve intersects with x-axis at x equal to 2a there. So the curve look like this. I will show you here. This is the curve that I am saying. So whatever this curve is there, this is a 27ay square is equal to 4 times x minus 2a bracket cube. So this is only one example where you require this curve. Okay, so you should remember this curve. This is the curve that you have. And y square equal to 4x. Y square equal to 4x is not new. This is the curve that y square equal to 4x. So this curve is y square is equal to 4x. Okay. Now we are rotating this region between these two curves. If we observe, whatever the solid generates on the upper side, the same solid is generated by this lower side. So we are taking only this part. We are going to take this part only. Okay, we are going to take this part. This part is only rotating about an x-axis, and we are to find the volume there. So how to get a volume, the required volume generated by this solid? Yes, anyone have an idea? Our aim is to get this area, this volume of the solid by this area only. This area only we want to rotate about an x-axis. Any guess, anyone?
Volume by the curve of parabola minus the curve.
Very good, nice answer, correct. So first we should find out the volume generated by a parabola. You will get this up to this one. You will get entire this volume generated by that part. But later on we have to we don't want this part. We don't want this one. Okay, so the other part we don't want there. So this one actually. So this we have to remove. So minus the volume generated by that evolute there. This evolute. Okay. So you'll observe pi y square dx. V is equal to pi y square dx is the formula. We taken 0 to 8a. 0 to 8a gives you the volume for the parabola. So remember this point of intersection you have to calculate. So x is equal to 8a. That about the intersection point. This is the 8a point. So that you can find out by solving these two equations simultaneously. And then this is the point x equal to 2a. So x equal to 2a to x equal to 8a for that evolute. So this is the volume by a parabola. This is a parabola, this part, and this volume is of evolute, this one. Okay. And now remaining part is just replacement of the value of y square. You will observe the value of y square can easily replace for here, and the value of y square can be replaced in this second one, and just we have to integrate it. So y square equal to 4x is replaced in the first part, and this is the value of y square replace this constant taken outside. Integration, integral of x minus 2a bracket cube is x minus 2a raised to 4 upon 4. Upper limit minus lower limit, simplification, and the required answer. Required answer is 80 pi a cube. 80 pi a cube is the volume of a solid, volume of the solid which is rotated about an x-axis there. Got it? Any doubt? Anyone have any doubt here?
No, sir.
No. Okay. So the next one, last two examples, total 4 examples I'm taken here, and that are enough, more than enough. First of all, generally this article not asked in last 7-8 years. I already told, not so important topic. Just for as this article is in a part of a syllabus, we are completing it. By chance, if it come, you should able to answer it. But 99% chance is that the question will not come in the exam on this part. So the question is here, prove that the volume of a reel, this is the new word reel that comes mainly for cycloid only. This is again one more new curve for you. Cycloid is a curve which look like this. I will draw the cycloid here. There are different cycloids there, but I will draw this one only. So on x-axis there is theta. Sorry, my mistake. This is x-axis only. X and y values we have to plot it. Okay, no issue. So when theta is a 0, can you tell me the value of x and y? Yes, anyone? When theta is a 0.
0, x is equals to 0.
0, y is 0.
Y
Correct.
equal to 0.
Very good. So when theta is 0, x is 0, y is 0. So this point is 0, 0. Okay, the first point we got it as a 0, 0, this point. Next, theta is a pi by 2. So here is a pi by 2, sine pi by 2 is 1. So 1 plus pi by 2a and cos pi by 2?
0.
0. So that is only a there. Okay, so y is a and x is something. So, somewhere here you get x and y is a. So somewhere here you get that point. So this point is obviously that a uh, pi
1
by
plus
2
pi
plus
by
1
2.
and a. Okay, that point. Okay, so that way. So cos pi, next you will observe this, next time you will get this value, then this okay, we'll not go in further. So again you will get, so this is a one reel. I will this is like one sine wave. Okay, half sine wave. It is known as a one reel of a cycloid. So this is theta equal to 0. This point is theta equal to 0 and theta equal to pi. Or in simple word, I will tell you, in simple word, the real of a cycloid is always between theta equal to 0 to pi. Okay, you will get one real of a cycloid between 0 to pi always. So these are actually, this cycloid is a periodic curve. After this, it will be like that only, like that only. So this is 0 to pi, pi to 2 pi, 2 pi to 3 pi, and so on. So right now, only this one reel, only this part, we are rotating about an x-axis. So this one only, we are rotating about an x-axis, and we want a volume of that reel now. Volume of the reel formed by revolving about an x-axis there. Okay, got it? Diagram is not required. It is just for your understanding. I drawn it. Okay. So what is the formula? Formula for volume?
Pi y square
Correct.
dx.
Pi y square. What is the value of y we should replace? What's the value of y we should replace? This one, na?
A1 minus cos.
Yeah, correct. What is the value of dx? Dx is from here. A d theta cos theta d theta. Is it? And it is 0 to
Yes, sir.
pi. 0
Yes,
to
sir.
pi. It is a 2 times return. Actually, I think it should not be a 2 times. Let me see here. It should not be a 2 times, I think. Okay, we'll move. We'll check it. Pi y square dx. 2 pi is written. 0 to pi. Value of a square 1 minus cos theta bracket square a into 1. What should be a next step for integration? We'll think about this too. Okay, we'll check about this too at the end. Can you first tell me how to integrate now?
So you multiply it and one will be sine square.
What is the value of 1 minus cos theta?
2 sine square theta by 2.
Yes, it's better to convert in half angle formulae. It is a 2 sine square theta by 2 and it is a 2 cos square theta by 2. So that way we'll proceed. So 2 sine square theta by 2, 2 cos square theta by 2 is replaced. Half angle formulas we used. Now, obviously, we can use a substitution theta by 2 as a t. So the limit goes in 0 to pi by 2, which is the required limits then, is it? So let theta by 2 is a t, that, or you can use any other substitution there. So that you can do it. First, it is just simplified the numbers. Theta by 2 equal to phi is replaced. Okay, so limit goes 0 to pi by 2, is it? How to integrate
Yeah.
now? How to integrate this?
Sir, beta.
Beta.
Not
Always.
instead of
Wallis formula.
Wallis formula is the
Wallis.
best. Beta is also correct, but beta is little lengthy. It's better Wallis formula because integer power is there. So what is the value? Tell me. Let me see who is able to apply Wallis formula. Yeah. So when you apply Wallis formula for this one,
3
yes.
upon 4 into 2 upon 1 into
N
pi 1.
minus 1 is 3. 3 into 1. Okay. 2 minus 1 is 1. Divided by, yes.
Sir, 4 into 2.
No,
4,
no.
yes.
4 plus 2 is a 6, na? M plus n. So 6
Sir,
into
6.
4 into 2. Is it? Into
Pi by 2.
pi by 2. So this is the value by Wallis formula that you should know. And that is the answer. You'll observe pi square a cube is the answer. Now only the 2 is, I have to check about this 2 only. So if theta is a 0, let I check it. Okay, simultaneously you can just, can you check what are the coordinates we get for theta as a pi? If you replace theta by pi, what are the coordinates of x and y? If theta is a pi, cos pi is a 1, so y is a 0, na? I think 0 to pi is only 2 times should not be there.
Sir, y is equals to 2a and x is equals to pi a, I think.
Y is 2a. How y is a 2a? Because
So cos pi is
okay,
minus
okay,
1.
minus
Yes, sir.
1.
Cos
Yes,
Yes,
pi is
sir.
-1.
-1 हो रहा है, तो -1 तो 2a आ रहा है ना, तो
But y is 2a.
okay,
Yeah.
okay, so my mistake then. So my mistake. So the graph I not drawn it correct. Let I draw the correct graph of one reel of a cycloid then. The cycloid graph will go like this. So here is theta. So this is one reel of cycloid, but this point is for theta equal to 0. Okay, this point is for theta equal to pi, and this point is for theta equal to 2 pi. So because of that, it is taken 2 times 0 to pi, 2 times 0 to pi. So whatever this rotation is there between 0 to pi, the same
Symmetrical
yes,
rotation.
symmetrical rotation. So this is the graph of cycloid. Cycloid reel is between 0 to 2 pi then. So my mistake there. Okay, and somewhere here pi by 2 point is also there. So if you want, this is theta equal to pi by 2, but not to go in that detail. Okay, so that's a graph of cycloid for this is again 2 pi to 4 pi. You will get similar part of cycloid there. Any doubt?
Sir, how can we avoid these mistakes like if we don't know how to draw the curve?
No, I already told for cycloid you should remember cycloid one reel is at always between 0 to 2 pi. So don't worry then. Okay, always you take a limit from 0 to 2 pi, or you can take 2 times 0 to pi. Got it? Don't draw the curve at all.
Yes, sir.
Okay, don't draw the curve for cycloid. You take limit 2 times 0 to pi or only 0 to 2 pi directly. Okay, only these two examples are there. Actually, chances are very rare to come this question, but yes, part of the syllabus there. Last question then. Okay, probably last or second last. Okay, second last. Volume generated by a cardioid now. R equal to A 1 plus cos theta. Which cardioid is this one?
Right hand side.
Right hand
Right hand
cardioid.
cardioid.
Correct. Very good. So the cardioid is the right hand, but the formula we should you should remember it's a 2 by 3 pi r cube sine theta d theta. Now, is the limit correct? 0 to pi?
Yes, sir.
2 times.
Why 2 times? Why 2 times?
Pi by 2, sir, limit, I
See,
think.
this is the right hand cardioid. This is theta equal to 0, and this point is theta equal to pi. And whatever the curve, whatever the solid we generate from 0 to pi only, that same solid gives pi to 2 pi. So there is no need of 2 times there. Is that clear? Because this part
Okay,
is
sir.
only enough to rotate. So 0 to pi is a correct limit. Value of r cube we have to replace. Value of r we have to replace from here. How to integrate now?
1 plus cos theta t.
1 plus cos theta is a t, that is one way, correct? One of the way is substitution, put 1 plus cos theta is t. Other way is a half
Half
angle
angle
formula.
family.
Yeah, correct, half angle formula. So I think I done by I check. Yes, substitution. 1 plus cos theta considered as a t, then minus sine theta d theta as a dt. Okay, and this integration is there, upper limit minus lower limit, and the answer is 8 by 3 pi q. Okay, half angle formula is also the alternative way there. If anyone have a doubt, most important thing for volume of a polar curve, you have to remember this formula. Formula is main part. Got it?
Yes, sir.
So I will show you the last question then. Last question is on surface area. Surface area of a cardioid about an initial line. What is the formula for surface area?
2 pi SDS.
2 pi y ds. 2 pi y ds. That is a formula. But ds we should calculate first. The formula for ds is the root of r square, root of r square plus dr by d theta bracket square into d theta. So here is a r there. So r square you can replace dr by d theta. We have to replace and we have to simplify that. So this is the r square and this is a dr by d theta square. Okay. So squaring and simplifying, we get this value of ds there. First we calculated ds. Formula for surface area is a 2 pi y ds. Value of y is r sine theta. Value of y is r sine theta, and ds we calculated here. So this is r sine theta, value of y. 2 pi is a constant outside. This is the value of a ds. Again, value of r is replaced. This r. Here is r. So that r is replaced as a1 plus cos theta. Now this is in half angle. So everything can be replaced in the half angle, so that we can use a half angle formula. Simplified, 0 to pi can be considered as a 2 times 0 to pi by 2 also, and then you can use that theta by 2 can be replaced as a t, and you can use that Wallis formula also. But here substitution method is used, and by substitution method it is done. But by Wallis formula also you can do it, but you have to replace theta by 2 equal to phi or theta by 2 equal to t also, and you will get the same answer, 32 pi a square upon 5. That is the surface area of a cardioid. Is that clear?
Yes, sir.
Okay.